This video will focus on the target. I can determine atomic mass, mass number, the number of neutrons, protons, and electrons on an atom. So it's basically a target that focuses on counting subatomic particles. So almost all your information about your atom can be found on the periodic table. And in the end, we will solely use the periodic table to get the information. For this unit, though, there'll be a little bit more we do. The first number you'll need to use, and you'll use all year, is something called the atomic number. And the atomic number is found on your periodic table. In any box on your periodic table, it's the whole number. So carbon is 6 and oxygen is 8. So it's that whole number, it's not the decimal pointed. And that number actually refers to the number of protons in any given atom. Okay. If we're dealing with an atom and not something called an ion is a positive or negative atom. So if you're just dealing with a neutral atom, then you can also assume that the atomic number is your number of electrons. Okay, that's not always true. The atomic number, by definition, gives us the identity of our substance. So if we have an atomic number of 6, that's carbon, which means 6 protons. If for some reason instead we have, 7 electrons, that could be carbon or it could be something else. So electrons don't determine what the atom is. The proton number does, and that's what the atomic number is. So the atomic number defines the atom you're working with, and it always, always, always deals with the proton. In order to figure out your number of neutrons, you need something called the mass number. And the mass number is not found on the periodic table. Okay? The mass number is just protons plus neutrons. That's it. And while we do have another number in every box, that non-whole number, it's not your mass number. And that's because that number is an average. It's an average of all of the masses of all of the atoms. Every atom has more than one mass number, because while carbon always has 6 protons, sometimes it has 6 neutrons, sometimes it has 7 neutrons, which would give different mass numbers. So a mass number has to be a number that I give you in order for you to calculate number of neutrons. So to find neutrons, you would just take whatever mass number is given, subtract away the atomic number, and that would be your number of neutrons. Because I need to be able to communicate to you the mass number, there's a couple different ways people do it. One way for me to tell you what the mass number is something called the shorthand notation, where I either write the name of the atom or just use the symbol for the atom, like carbon is a C, and then you go dash and a number, and that number I'm giving to you is the mass number. So that's the number of protons plus neutrons. You would then get the number of protons from the periodic table, and you can figure out neutrons by subtracting. The other way we can do it is this subscript, superscript notation that's written down. That's always the symbol, and then you write the mass number up high and the atomic number down low. And then again, I'm telling you what the mass number is because there's more than one. Okay? This could say carbon 12 or carbon 13. If I asked you a number of neutrons from carbon 13, it would be 7. Number of neutrons from carbon 12 is 6. But the protons are always the same. Okay? The atomic number is the number of protons. That's it for this video. Have a nice night.